Welcome everybody to today's Getting Started with Kubernetes and Rancher online training. We have a lot of people joining the line. Really excited to do this presentation for you, this training for you. We were at our big company get together last week, so we couldn't host this training, but we were starting again. We got a ton of people today, so it should be a fantastic training. We have about 90 minutes with each other and a lot to go over. So I'm going to go ahead and dive right in. I do want to let you know that this session is being recorded. It's available after the session. We'll send it out through email. You'll get the video recording with the audio, Q&A, and all of the slides. So let's go ahead and jump on in. Today's objectives, what we hope you get from this training, we really want to give you a solid technical introduction to Kubernetes using Rancher. We will go over Kubernetes concepts, Kubernetes fundamentals, components of Kubernetes, and we'll do a lot of demoing. So we do have slides to help you understand the concepts of Kubernetes using Rancher, but we will mainly and hopefully do a ton of demoing so you can see how it all works and how it all fits together. Please ask questions. This is very much intended to be for you, to serve you all in what you want to understand in coming to this training. It is meant to be an intro level training, so if you can keep it at that level, that's great. If not, it's okay. We'll still make this commitment to not leave before all questions are answered. We do our absolute best to make that happen. We do have 90 minutes scheduled for the training, and we have gone long, as the case may be. One thing that we would love is, to get better at these trainings, do a better job of educating about these topics that we love, these technologies that we love. So we really appreciate your feedback. There is a survey at the end, and if you leave, sooner, the survey will be offered, and I think it'll also send out through your email as well. So if you're able to take a couple minutes to answer that, it's super, super helpful for us in improving these trainings. So just a quick way of introduction. I'm Matthew Shear, kind of like community advocate at Rancher. You can reach me through Twitter or through my email. Please reach out if you have questions. We also have Adrian on the line, who is the main presenter. We'll be getting really into the heart of the material. His picture is bigger than mine, obviously, because he's really delivering all of the value to you guys.
Hello,
Hey,
everyone.
hey. And of course, he loves being connected with, so you can reach out to him on Slack or on Twitter, and we try to make ourselves really available. One other thing that I want to let you all know is that we have a training channel just for the members of this training. So if you go to slack.rancher.io, sign in there. It's totally free. There are thousands of other members of our Slack channels who daily talk about Kubernetes, Docker containers, all sorts of stuff with this open source software. And if you join the hashtag training-0124 channel, that is specifically set up for you all. And it is meant for you to ask each other questions, get to know what, how you each are using this technology, problems you're running into, and just further connect as a class. If you want to talk with us, please put it into the GoToWebinar chat that's in the panel as you're watching the presentation, and that way we can answer your questions quickly. A little bit more context before we really dive in. We hope that you come to this training with some basic understanding of Docker, some basic container concepts under your belt. If you don't, I think you'll still get a ton out of the training. There's a lot of material online on our website, rancher.com, on our blog, in obviously Docker's docs as well. So you won't be without resources, but this will cover more Kubernetes and Rancher concepts building on Docker. And again, I think you'll still get a ton out of the material. Feel free to ask questions, though, if you do get lost. If you want to follow along with the demo that Adrian does, you can have your own instance of Rancher started. It's free. It takes just a couple minutes to get it installed. Go to rancher.com, click that deploy button in the top right corner, and it'll take you to the quick start guide. You'll be able to get your own instance running in just a few minutes. Couple more resources. As I mentioned already, the Slack channel is great for you to connect with each other and to connect with other engineers and users who are dealing with this stuff day in and day out. We also have a forum that again is free for anybody to join. Forums.rancher.com. A lot of longer discussion, in-depth discussions going there. We also make product announcements and other release announcements on our forums. So with all that out of the way, we can get into the heart of the material. So I am going to pass this presentation over to Adrian. And I'm sending it to you, sir.
Show screen 2. Okay, I'll try to remember that.
There you go. I can see just your slide. That's great.
Nice, nice. So hello everybody, my name is Adrian Goins. I will be your trainer for today, and I want to take a moment to apologize in advance if I suddenly sneeze or mute myself or stop talking mid-sentence, because I am sick today. I have a small fever, I'm congested, none of that matters to you. I will do my best to not sneeze into the microphone. So if I do, I apologize, but if I suddenly disappear, just hang tight. It means I'm sneezing in the background, and I'll be right back. So let's go. I always run long on these trainings, and there's a ton of information. We're going to make some changes in the future to split this into a Kubernetes training and a Rancher training so that I've got the time to introduce you to the concepts that I think are most important as you're going down this adventure into Kubernetes and Rancher. Let's start here. You're here today because you probably figured out that Kubernetes has taken over the market, and you might even be here wondering why you should care. Honestly, it doesn't matter if you believe in Kubernetes or not. If you don't learn how to use it, it's not too far in the future that you're going to find yourself unable to compete for jobs against people who do know how to use it. So I want to say thank you for coming. You've made a great investment into your future. Let's skip to this slide. If you've deployed Kubernetes, you've probably encountered some of these issues. It's got massive participation from what seems like everyone on the planet, but it still has its challenges. So you might have wondered, how do I deploy consistently across different infrastructures? How do I implement and manage role-based access control in my clusters? Can I plug my Kubernetes cluster into some backend system like Active Directory? If you've done any further exploration, you probably run into questions around single cluster multi-tenancy, multi-cluster environments, how do you manage that stuff, high availability, security policies, monitoring. Like Kubernetes deployment is where you start, and then you'll progress into answers for these things. I recognize that one of the questions about deploying Kubernetes is, everybody's like, well, it's really popular now, but so is Bitcoin. So, how do I know Kubernetes is going to be, nothing in a year? I can tell you that it's not. It has so much traction in the industry right now that it's here to stay, and it's only going to get better. But you still want to make sure that whatever solution you deploy today is effective tomorrow and meets your needs far into the future. And since you're at a Rancher online training, it wouldn't be right if we didn't tell you that Rancher's here to solve all of those problems. You can pick your Kubernetes solution. You can build it yourself the hard way. You can build it the easy way with Rancher Kubernetes Engine. You can put it in the cloud. You can use a hosted provider. It doesn't really matter where you get your Kubernetes. Kubernetes is a commodity. Rancher can launch instances and install Kubernetes onto them. It can deploy and manage a hosted Kubernetes solution running in any provider. If you already have a Kubernetes cluster or multiple clusters out there in the wild, you can install Rancher and then import those clusters and immediately apply strong role-based access control uniformly across all of them. Rancher makes it possible to manage Kubernetes clusters. But what does management really mean? Well, it means that you're going to corral all of your clusters under one system, one highly available point of control, and you're not going to sacrifice any of the individual cluster independence. It means that you can bundle namespaces into projects and then map strong authorization roles that grant the correct level of access to those projects. It means that Active Directory or SAML or whatever infrastructure you already have can control access to Kubernetes clusters running anywhere in the world. And it means that you can readily see and control your capacity, and thus you can control your costs. You can scale infrastructure up or down based on metrics that you control. If you're an administrator, operations team, that probably sounds really exciting. But if you're a developer, you're probably back to why should I care? There's a lot of stuff that Kubernetes enables for the people who are using the clusters. I mean, maybe you just want to spin workloads up and down quickly. Maybe you want to have API access to them. Rancher gives you tools to do all of that stuff easily and effectively. You can plug them into CI/CD systems. You can deploy instances and do all of the installation components, everything. So imagine it as a developer that as part of your QA process for code, you want to build a new Kubernetes cluster, deploy your code onto it, and then generate a URL for your QA team to do functional testing or user acceptance testing. You can do all of that with Rancher on a single push of code into your CI/CD system. If you want to package your application with Helm and make it available to others, or if you want to package it and make it available to downstream consumers within your organization, perhaps other teams, you can do all of that with Rancher and our application catalog. Rancher gives you total freedom to do everything that makes sense with a Kubernetes cluster, no matter where it's running, and it's 100% free and open source. There's no split level community version versus enterprise version. We do sell support contracts for companies who want it, but the software that you'll see me demonstrating today is the exact same software that you can use if you go and download it. It's all there. All right, let's start talking about Kubernetes. Kubernetes has basic building blocks, and while it's complicated, I think it's mostly complicated because it has a crazy name, like Kubernetes. That just sounds scary. It means helmsman. When you break a Kubernetes environment down, it's small components that you wire together into larger applications. And that's it. If you've done work with Docker, there's going to be a slight change in the lexicon, in the naming convention, and what things are called. But once you understand that, it's really not that hard. We'll start with pods. Pods are the smallest unit that can be deployed in Kubernetes. So imagine that you're sitting there with a container image that you want to deploy. In Docker, you might just use Docker run to launch it. Maybe you expose the ports so that something outside the host can hit it. But what happens when you want to connect it to other containers? Have you ever gone through the hassle of linking stuff together? Have you ever ported an app that expected MySQL to live on localhost? If you've got 2 containers, it's not a big deal. Once you've got 3 or 5 that are running on different hosts, it rapidly becomes a hassle. Remember that everything that we're doing, all of this technology that we take on and that we spend all of this time learning is not supposed to make our lives more difficult. It's supposed to make our lives easier. So keep that in mind as we continue through. A pod collects 1 or more containers into a shared unit with combined network space and combined storage. That's it. 99% of the time, you're going to have 1 container per pod, but sometimes you won't. Best practices always dictate that a container should run a single process, period, and that's often difficult to do. Pods make it easy to do that. If you think that this is confusing, don't be alarmed. It's new. You're usually going to have 1 container per pods. For the rest of the training, if you want to just hear container when I say pod, that's totally fine. But here's an example of multiple containers in a single pod and how they might work together. This has something that's pulling content from some external source, maybe a, I don't know, S3 or something like that, or maybe people are pushing content up to a CRM. And so it pulls it down, puts it on the volume, and then the web server makes that available to consumers to consume, which is what they do. When you launch resources in Kubernetes, you create what's called a manifest, and a manifest is written in YAML. You then use a command called kubectl, kubectl, or kubectl, whatever you want to call it. I say kubectl usually. So you use kubectl to apply the manifest. It's funny, I was pausing now because I wonder what I actually do say. Whatever. You use this command to deploy stuff to the cluster. So here I've got a basic manifest for a single pod. All manifests have 4 required keys. That's API version, kind, metadata, and spec. This is a simple pod that's going to print some text, and then it's going to sleep for 10 seconds, and then it's going to exit. But ask yourself, what's going to happen when it exits? All right, we are on my home cluster in the training namespace. And here is the exact same manifest that you saw earlier. Now, with Kubernetes, with kubectl, there are a bunch of different ways to launch things. And you'll see me use different methods throughout the course of the training. And it's just because I want to introduce you to the flexibility that you have depending on what you like doing or what you're trying to do at a particular moment. You'll also see that I've abbreviated kubectl into KC because as a system administrator, it is imperative that I be lazy. I don't want to type more keystrokes than I have to. I have to type enough of them every single day as it is. So here we're going to apply this manifest to the Kubernetes cluster. And it says, hey, okay, cool. What happened? Well, it's in container creating status. And let's hang out for a second with the -w option to kubectl get pod. And you'll see now that Kubernetes kubectl continued polling it, and it updated when the status changed from container creating to running. Oh, but what happened there? Well, it said it completed, I suppose, because it's just going to sleep for 10 seconds and then exit. And what happened? Kubernetes restarted it. 10 seconds pass. It completed again. And watch what happens next. When you run something inside of Kubernetes, a pod or replica set or a deployment, generally the workloads that you're running are workloads that are supposed to stay running. You can have things that run and then exit. Those are jobs or cron jobs, and we'll cover those a little later on in the training. But Kubernetes is responsible for making sure that what you told it to run stays running. When it dies, it restarts it. And in this case, it detected that it's dying frequently, and so it will step back the frequency with which it restarts it. It'll take longer and longer and longer because your Kubernetes cluster shouldn't be just banging on something that's crashing that saps resources from the rest of the cluster. This will continue to back off further and further and further and further and further. But for now, let's just delete it. All right, so that's been deleted. What we just created was a single pod. That pod had a single container in it, it did a thing, and it exited. The next layer of abstraction above a pod is called a replica set. A replica set is a resource inside of Kubernetes that defines the desired scale and state of a group of pods. Basically, that means that it tells Kubernetes how many pods to run and what they should be doing, which in this case is running. So for example, if you tell it that you want 3 replicas of a pod, and replica is simply a fancy word for copy, if you want 3 replicas of a pod and there are none, then it will do its best to make 3 of them appear. Here are 3 nodes, each running 4 replicas of our pod. Kubernetes has been kind enough to spread them out evenly across the cluster. But what happens if a node dies? Kubernetes saw that we wanted 12 replicas and that it only had 8. It did what it does, and it moved us from the actual state to the desired state. Those are very important terms, and this is how Kubernetes manages state. It's always working to maintain the desired state. Kubernetes monitors the health of the pods. You can set up health checks with HTTP, TCP. You can run a command inside the container, or you can just leave Kubernetes to determine if the pod is running or not, and it will restart stuff that way. There are also 2 types of health checks, liveness checks and readiness checks. So for example, a pod will not receive any traffic until it passes the readiness check, like if it needed to prime a cache or do something. And then once it passes the readiness check, it'll go on to the liveness check to help Kubernetes determine if it's alive. If you only specify 1 health check, it just becomes both of them, liveness and readiness. You can also configure health checks to start after some interval. So if the pod fails the health check, to start after some interval so that perhaps it needs 60 seconds to start up like GitLab does. And if the pod fails any of these health checks, Kubernetes will kill it and start a new one. So let's go and talk about replica sets. You're basically never going to launch a replica set directly. But it's important that you understand the concept. Here's a manifest for a replica set. You can see it's got the same 4 keys: API version, kind is a replica set, metadata, which includes the name of the replica set, and then arbitrary labels. So in this case, we're saying that the app is Nginx and the tier is front end, but these can be anything you want, simple key value pairs. Kubernetes uses these for selection. We'll talk about that a little bit more in a second, then you'll see it a lot as we go through the rest of the training. Spec. This tells Kubernetes what we want the replica set to do. In this case, we want 3 replicas, and we'll jump down here to the definition of the container. So we have one container that we're running in here. It's called Nginx. It's going to run this image right here. And then we've set some resources on it. I'm not going to actually get into that today. And we tell Kubernetes that this particular container is listening on port 80. That will be relevant in a bit. Having defined the pod that the replica set is managing, the replica set has to know how to find those pods. And this takes us back to labels. So you can see down here in the template for the pod, before we even got to the containers, in the template for the pod, we are setting some labels that will be on the pod. We're setting app equals Nginx and tier equals front end. Now, don't be confused that those are the same labels that we also have on the replica set. That's normal. Generally, you have collections of things that all correspond to the same thing, all having the same labels, because it just makes your life easier. So we have a pod with 2 labels. And then here, we actually have 2 different ways that we're telling Kubernetes to find the pods that belong to this replica set. One is a direct match label. And we're saying if there's a pod with a label of tier equals front end, it belongs to this replica set. Or you can have it look for expressions. Essentially, we want to know that the key is tier and that whatever value exists is in this list of potential values. In this case, we have 1. So we match both of those. Tier front end matches this directly. It also matches that tier is that whatever the value is a member of this list. Showing that just to show that there are lots of different ways to do things, but it's also worth pointing out that if you go and launch a standalone pod that also has a label of tier front end, you're going to screw up your replica set. So don't do that. How do you prevent doing that? Well, you don't launch pods directly. You don't launch replica sets directly. You launch them from deployments, which we'll cover next. But first, let's go launch a replica set. Boom. And you'll see that we have a replica set. We want 3 pods. We have 3 pods, and we have 3 pods that are ready. And now if I say KC get pod, you'll see that the replica set created 3 pods, which have a name followed by a unique identifier and what their current status is. Pretty simple. If I delete the replica set, you'll see that it not only deletes the replica set, but it deletes everything that the replica set controls, which in this case are the 3 pods. And this will continue on until they're gone. No replica set, no pods. Now we talk about deployments. Deployments are the next level of abstraction above a replica set. They give you a really nice set of commands within kube control that you can use to control replicas, do updates to images running in the pods, and so on and so forth. Deployments are one resource type. In today's training, we're not going to cover other ones, but understand that a deployment has pods that are identical. So you scale up, it just launches more pods that are identical. There's also a stateful set. Stateful set is used for things like databases or things that have replicas where state matters. So MongoDB, Redis, MySQL, any of those things would be a stateful set. Then there's daemon sets. Daemon sets run one copy of the pod on every host. So if you have 3 nodes in your cluster and you fire up something that's a daemon set, it's going to put 1 pod on each of them. And when you add a 4th node, it's just going to put a pod on it because it knows that it's part of a daemon set. Then there are jobs, which are containers that do something and then exit. Kubernetes will not restart them. And then there are cron jobs, which work just like cron on a Unix or Linux system, where Kubernetes will run the job exits, and then at some interval that you define later in the future, it will run the job again. So you can imagine using that for like backups or image processing, stuff like that. So here's our replica set again. We've defined a deployment that says we want 4 replicas of our pod, and each of them are running an image with a specific tag, like version 1.0. I'll pause here to tell you that within Kubernetes, you never want to run images with a tag of latest or with no tag at all. The reason for that is because these things are stateless. They're ephemeral, and at any point it could die, or Kubernetes could decide that it's not working properly and kill it and restart it. If you use a tag of latest, or if you use no tag, which is the same thing, then when you launch that pod or when it relaunches on its own, Kubernetes is going to go out every single time and pull down that image. So if you're running stuff that's version 1.0 and whoever manages that actual container image decides to release version 2.0, and in the middle of the night your container dies or your pod dies and Kubernetes restarts it, now you've got some of your stuff running 1.0, some of your stuff running 2.0, and that's just a recipe for disaster. So all the time, every single time that you deploy anything within Kubernetes, use a specific version tag. If they don't provide a specific version tag, send them emails asking that they do, but you can also use the container hash or the image hash to stick a particular release. Anyway, I digress. So we're running a container with a tag of version 1.0. New version comes out, tagged 1.1. We want to roll it out. So we update the deployment manifest, or we directly tell Kubernetes to deploy new pods with that image. And it starts doing what we ask. So it can either start new ones while the old ones are running, or it can kill the old ones and start new ones later. Which one you choose is determined by the resources that your pods are using, and you control all of this. So for example, if you have a pod that uses read write once iSCSI volume that can only be mounted in one place, you need to kill that pod before you can start a new one that uses the same storage. Otherwise, your new pod will just sit there in a pending state forever. The rollout continues as Kubernetes continues to deploy new things and kill old things until we have 4 pods running the new image, and that becomes our new deployment. So Kubernetes understands that we move from one state to the other. If for some reason version 1.1 doesn't work, we can roll back to the previous version. And Kubernetes itself lets you roll back one version, but Rancher keeps a diff of all of the configuration changes that have happened within your application, and you can roll back to any previous version from any historical point in time. I'm going to pause for a moment and drink some tea. So now we have a deployment, 1 or more pods, but how do we talk to them? Pods have a shared network space under one IP. So each of these pods has its own IP address, but that IP is mutable. And Kubernetes can kill a pod and restart it, and it's going to get a different IP. So you never want to talk to the IP of the pod, because eventually you'll be sending traffic to a pod that doesn't exist anymore. We handle that with services, but before we do that, let's get a demo of deployments. Here, it's a little easier to see. Here is the manifest for a deployment. And it uses basically the same stuff I covered in replica sets a moment ago. How many replicas do we want? In fact, it looks almost identical. The only difference is that it's a deployment instead of a replica set. So that should be easy enough. Instead of deploying this with the manifest, because this is pretty much just stock other than the label, I'm just going to deploy the image directly. Remember I told you that there are lots of different ways to do things in Kubernetes? Well, here's where you start seeing me show you different ways. So kubectl has a create command. So you can say kubectl create deployment nginx -- image equals nginx 1.14 -outline. And you'll see now that we have an nginx deployment. We have an nginx - unique identifier replica set that was created by the deployment. And we have a pod, which now contains the name, the identifier of the replica set, and an identifier for the pod. Cool. And it's running. And that's great. Now let's delete it. Gone. And we say get pods. You see everything gets deleted. So another way that we could have done that is apply -f deployment.yaml, and it does the exact same thing. Now, at this point, you may be curious what else we can do besides deploy things. What if something was going wrong? What if we were seeing crash loop back off or some other kind of stuff? Well, you can get logs for your pod. Now, in this case, it's only one container running inside of it, so I don't have to provide a container name, but if there were multiple containers, I would. So I get the logs. There's actually no logs for that. That's not very exciting. Or I can get information about the pod from Kubernetes. You do that with the describe command. And here's a whole lot of information about stuff and things, most of which you don't need to worry about right now. There's like its port, it's not on a host port, that's cool. What storage is mounted, various other things. But events is interesting. So if you encounter a Kubernetes error, this is where you'll find it. If you encounter a pod error, you'll find it in the container logs for whichever container is failing within the pod. So you can see that, cool, we already had that image present on the machine, so it just created it and it started it. Easy enough. Now, what if we want to run more than one of these? So we have one. Well, let's scale it. We'll say we need to run 3 of them. It's going to start rolling that out, and probably faster than I can, yeah. Because it's an Alpine image, it's really fast. So it spun up 2 more. Now they're all running. But this rollout status command tells Kubernetes to tell you what the process is as it's rolling out additional replicas. So let's actually, yeah, we'll hit this again later. Okay, now let's use my example earlier of we wanted to go from 1.0 of something to 1.1. A number of ways we can do that. In this case, we are going to use the set image directive to kube control. And because we can have multiple containers, here I do have to say which container I want to update. So the container inside of the pod is called Nginx, and I want this to run. And some of you may have noticed that I mistyped that. Don't be alarmed. Okay, so it's been updated. The -- record parameter is what allows us to do a rollback. If you don't provide that, well, just always provide it. So now we say get pod, and oh, we see that, first of all, the 3 pods that we already had running are continuing to run. And we see now that our new pod has failed. Image pull back off. What's the problem? And you'll see down here, failed to pull image. Oh, I misspelled Alpine. Error image pull. So Kubernetes will just hang out here until I fix this. And there's a few ways that I can fix it. The easiest is going to be to undo the rollout. And it'll terminate that pod that it was just trying to start. And, our production environment stayed up and running the entire time. Nothing's changed. Super cool. Here's another way that you can do that same change. kube control gives you the edit command, which will bring down the manifest from the cluster itself. And here, I'm just going to, so there's my cursor down there. I'm going to change that to 1.15 Alpine. And this does YAML validation. So if you screw up the YAML somehow, it will fail to apply it, and then it will take you back into it and tell you why it failed. In our case, you can see that we're in the process of pulling down the new image, and it'll just continue to update us here as it rolls out the new image. And now it kills off the old ones. Cool. Services. So now you've got some stuff running a bunch of pods, but that doesn't do you any good if you can't actually get to it. I mean, all this is inside the cluster. It's not exposed on the host. It's not exposed outside your network. So it's an exercise in futility. Because pods are effectively transient, we need a stable endpoint that tracks the comings and goings of pods as they get upgraded and rebuilt and relaunched and stuff like that, and spreads traffic uniformly across them. That's what a service is. A service can be one of various types. Cluster IP gives it an address within the cluster, and this is suitable for use with ingresses, which we'll cover in a moment, or for communication within the cluster. So imagine that you have a MongoDB replica set, and so you can put a service in front of it, and it'll handle routing traffic. Node port is the next service type, and services are cool because they're not incremental. They build on one another. So initial type is cluster IP. If you choose node port, it actually builds you a cluster IP service, and then it builds you a node port service. And a node port service opens a port on all of the hosts, and that port will talk to the cluster IP and so on. The thing about node port services is that it uses a high port by default within the range of 30,000 to 32767. And although you can specify the port for a node port, if you don't, Kubernetes just arbitrarily chooses it. So in and of themselves, node port services aren't super helpful because you don't want to be in the business of managing ports. So the next service type is called load balancer. Load balancer works if you're using Kubernetes within a particular cloud provider like GCP, AWS, GKE, and so on. When you deploy a service of type load balancer, the cluster knows how to talk to the cloud provider because you've told it how to do so. And it will reach out and, well, first it will build you a cluster IP service, and then in front of it, it will put a node port service, and then it will reach out to the cloud provider and launch whatever their load balancer solution is. So in Amazon, it's an ELB. And it will update and maintain the ELB node pool records to send traffic from that load balancer to the corresponding node port on all of the hosts. And then from there, it goes to the cluster IP service, and from there, it goes to the pods. It's pretty cool. It looks something like this. Well, okay, so those are services. And now let's demo some services. All right, do we still have something running right here? We do. Slick. Once again, because there are a lot of different ways to do things. In this case, I'll go ahead and deploy a node port service just so that we can talk to it with the browser. And so I'm telling it expose deploy / nginx type equals node port. The reason I can do that is because here I told Kubernetes where the container is listening. So there's only one container, there's only one port that's listening on. Kubernetes is smart enough to figure out that if I want to expose that via a service, that's what the traffic needs to go to. Cool. So here you are. You can see that this is the IP that it created inside of the cluster. External IP doesn't matter because this is listening on every single host in the cluster. And that's the high port that it created. And then it's sending that traffic to port 80 on the pods themselves. That means that if I come out here, I can go to Rancher 01 32297. And there's an nginx page. And I can come over here to Rancher 02. And there it is again. And I come to Rancher 03. Pretty easy. Now, looking at my notes here to see if I need to actually do this next part, because I want to try and keep us as close to under time as we can. Matthew, how many questions do we have so far? Curious, just so I can factor that in.
Just a few actually. So
Okay,
there's not a big backlog. Yeah, you're doing good.
Okay, cool. All right, yeah, let's go ahead and do this. Um, so I'm going to edit this deployment, and I'm going to come out here to container port. So I'm here. Isn't that a cool thing? I absolutely love that. It's command slash, and it tells me, because I lose my cursor in these screens. So let's remove this, and now, okay, so it launched some stuff. But now if I do that expose, it's going to fail because it couldn't find the port in the directive. Like I told you, was the reason that it worked before. So you're not always going to have that container port defined, yet you're going to be deploying services. So what do? You don't have to go and edit the manifest and edit the deployment and relaunch all of your stuff. You just need to tell Kubernetes what port to talk to, and it'll be happy to do so. Now, what if we wanted to specify the node port? Yay, look at that, there we are. What if we wanted to specify the node port for some reason, because we want to be in the business of managing ports? Let's delete that, and let's expose it. And this time we need to, all right, we'll do this differently, actually. We're not going to expose it. We're going to create a service of type node port. We're going to name it Nginx. We're going to say that we want it to be on a specific port. And we're going to say how to map it inside. So remember, node port service is actually two services. It creates a node port service and a cluster IP service. So now we've said, and it doesn't actually create objects. All of this translates into IP tables rules that just handle routing traffic around. So it doesn't really create anything, but it sends stuff to something that sends it to something else. So in this case, we're going to create a node port service that listens here. We're going to send it to a cluster IP service that listens there, and it's going to talk to the pods on that one. Yeah, there it is. And now if I run a curl against 31337, oh, there you go. Just to continue to demonstrate the various ways to do things, if you create a service or if you create any object inside of Kubernetes, just saying get service, as you see, it just tells us a little bit of information about it. But if I say, whoa, I locked my screen. Oops, sorry about that. There we go. If I say -o YAML, then it will actually print for me the YAML that it used to create the object. So this is cool if you want to deploy things and then extract the YAML from them and throw them into version control or something as part of your project, whatever. I think I actually have the service here. I do. So just because we need this to be a cluster IP service, apply -f service.yaml. Okay. This will allow us to move on to ingresses. So with all of that, I just showed you I created some stuff, I deleted it, I created it differently, I deleted it again, I did a bunch of things, and ultimately what we're left with is a cluster IP service listening here, talking to the pods on port 80. The reason we wanted to end here is because we want to talk about ingresses. And I'm going to pause after ingresses for questions. So if you have any questions, go ahead and throw them in the chat window, and Matthew will start collating them, and then we'll do it. After the questions, we'll do a demo of Rancher. Ingresses. Ingresses is a fancy word for getting traffic into your cluster. An ingress takes a service, and it exposes it outside of the cluster. So remember, we're doing building blocks here. You had pod, above that you have replica set, above that you have deployment, above that you have service, and now above that, if you're not using ELBs or whatever the cloud provider gives you, you have ingresses. Personally, I don't like paying $18 or whatever they cost now per site that I run inside my Kubernetes cluster. So I run ingresses, and I run a TCP load balancer that routes all of the traffic for anything to my Rancher nodes where it gets hit by this thing, and this thing makes routing decisions on where the traffic is supposed to go. You can just think of an ingress as a thing that exposes a service. Service lives in the cluster, ingress exposes it out. It's implemented by some type of software load balancer. Usually, by default, you've got the Nginx ingress controller. There's also HA proxy. There's traffic. There are ingress controllers from F5 and from A10. If you have their hardware solutions, there's lots of ingress controllers, and you can even run multiple ingress controllers and assign them to different workloads within your cluster. It's pretty cool. So going back to the microservices concept that I usually discuss earlier, but that I didn't discuss today. Imagine a microservices environment where you have different workloads running different paths on your website, like /search, /store, /catalog, or something like that. Each of those is going to be a different independently operating set of pods that you could scale up individually, and they're all going to do their own thing. So it allows you a lot of granular control. And then you would use the ingress controller to route traffic based on path to whichever backend it needs to go to. Ingress controller, this is my slide from earlier. It sits in front of the service IP and it does stuff. It'll respond to routing based on host header, based on path, based on cookies, based on, I mean, it's Nginx, it's a load balancer. So anything that you can do with Nginx or HA proxy or traffic or whatever, you can do with an ingress controller. It's extremely powerful. Let's just show it. Here's the manifest for a very simple one-to-one map between, well, essentially between an IP and an internal workload, so service. So you've got the same things, and here you've got rules. So I want traffic that comes in for training.cl.knock.us, which is my home domain, route / to the service named Nginx, and send it to port 80. It's pretty simple. There you go. Hey, look at that. I still have an ingress controller from the last training session. Okay, so we have created this single ingress on that host. And so now, I come back to my browser. And instead, if I go to training.cl.nanog.us, well, we still get the very exciting Welcome to Nginx page. It's very exciting. We don't know where this is landing on the host, and we don't care because these are stateless pods as part of a deployment, so it doesn't matter where they go. If we needed some sort of state in this application, then we would store state externally in something like Redis, and Redis would be running in a stateful set, and we would extract the state from a cookie or something, and then we would do stateful stuff. But for this demo, it's just some pods, and they're just running Nginx. Now imagine that we do the thing that I described earlier, where you want to route traffic from different paths to different destinations. So let's delete that. And let me show you this. So here, this is called a fan-out ingress. And it's just a fancy way for saying route to multiple destinations. So we use all these fancy words and fancy terms, so we sound smarter than we are. Don't be alarmed. Same host, / is going to go to the same thing, but now we want /rancher to go to a service called Hello World. Those of you who have been paying attention probably noticed that we don't have that service yet. So what do you think is going to happen? Let's find out. If I reload this, yep, that's cool. And now if I go to /rancher, the dreaded 503. Anytime you hit a 503, it simply means there's no backend to service this request. That's all it means. Either you didn't make one, or it's busy, or something. The load balancer has decided, I don't know where to send this, so I'm going to return this particular error to you. That's all a 503 is. Why did it do that? Because we don't have service. We don't have anything else that's actually running that. So let's fix that right now. So I'm going to create a new deployment called Hello World. I'm going to use the image rancher / Hello World. Now you see I have 2 deployments. You see that this guy is not yet available. Probably have to download the image. Okay, now he's available. Cool. I can't expose it. Do you remember why? You can't answer. It's kind of a rhetorical question. Hopefully you said, yes, I remember why. Because we need to tell it what port to use. So we have now, we've got deployments, pods, services, and over here, boom. So off the same domain, separate paths, and you can actually see, oh, that's only load balancing this one. So if I scale that, if I get this type, it's going to be done. Status, deploy, Helm. Yeah, it's done. So now back over here, if you notice this line, it should begin, yep. See how it changes? So it's actually load balancing the traffic against each of those backend pods. That's it for the Kubernetes part, and I'm actually doing really good on time. So I'm going to pause and take some questions. Matthew, what do we got?
Awesome, Adrian. So good. I'll just say, first of all, there's quite a few people have just said this is a great training. So thank you.
Oh, thank you. I'm glad you guys like it.
Yeah, and thanks for being here while you're a little under the weather. Okay, so
it's okay.
Yeah. So the first one is from Christopher. He says, "Is Adrian using a Rancher Docker right now? I don't get how he gains access to CLI and kubectl without using Rancher's webpage."
Oh, that's a fantastic question, and I will cover that when I demo Rancher in just a moment. I'm
Awesome.
using kubectl. There's nothing fancy here, but I'll explain how this is working with Rancher in a few minutes.
Okay, sweet. Okay, here's from Noah. Is the service IP bound to the master or something? I'm thinking of the master worker concept. I wonder if the load balancing dies when the master node dies.
Also a good question, and no. When you create... Okay, so here we have 2 cluster IP services. These are simply IP tables rules within the cluster itself. So I have 3 nodes in my cluster, and I'm running a particular networking provider that essentially wires them all together. So it's just one big network space. And Kubernetes knows which host a pod lives on and handles routing between hosts as necessary. So these IP tables rules work they work within all of the worker nodes. It actually has nothing to do with the master. In my case, my 3-node cluster, each of the nodes is also part of etcd, the control plane, and the data plane. But in a normal production environment, you would have your etcd nodes separate, your control plane separate, those would be the masters, and then your worker nodes separate. And all of this stuff, these services and things like that, exist within the realm of the worker nodes. So here, the cluster IP, it's just IP tables rules, communication within there. But as soon as I change this to a node port, it will actually open a port on every single one of the hosts in my pool of workers. And so any one of them can receive traffic, and it will route it within the Kubernetes overlay network to the destination pod or whatever, where it needs to go. In that case, you can kill a node, and the service, so you can kill a node, pausing here. So you can kill a node, and in that case, the question is, how are you getting traffic to each of the nodes? Let's say I have 3 nodes. I have node port listening on all 3 of them, and I'm using round robin DNS, where I take www.mydomain.com and I just say it has 3 A records pointing to each of those 3 nodes. In that case, if one of those nodes goes down, well, then 33% of my traffic is likely to fail. That's why you don't really want to use round robin DNS unless you have something managing those records, like a monitoring system that's updating stuff via an API. Sorry, it's a really long answer. Or put a load balancer in front of it. So in my case, I have an HA proxy load balancer, and it is doing health checking of the nodes. So if I were to power up one of the nodes right now, it's smart enough to say that node's dead and send traffic to the other 2 nodes.
Okay, awesome. Yeah, I think you touched on some answers to other questions. So Chris had asked, have you had any luck with load balancing other than round robin? If so, which have you used? With Nginx specifically.
So it's not a luck thing. Nginx you can configure to use whatever type of load balancing you want. Least connections, round robin. You can do cookie-based stuff so that people's sessions wind up on the same stuff, but that doesn't really apply here because our backends are stateless. Which you choose is up to you according to the needs of your application. In general, I just use Nginx's round robin because I'm not running stateful applications.
Awesome. Okay, here's the next one. Can you have multiple ingresses like Nginx and HA proxy?
Yes, you use what's called an annotation. Hang on, show you here. Annotations. Okay, so in the metadata for the pod, there are annotations, and you can do these arbitrarily. You would set an annotation in your deployment that says these pods and services and whatever are handled by this particular Nginx, or sorry, this particular ingress controller. So you can have HA proxy, you can have Nginx both deployed or traffic or whatever. And when traffic comes in to the corresponding ingress controller, pausing here. So the problem there is you can't do like what I've described now, where I basically have Nginx listening on port 80 across the board. And so I couldn't also have HA proxy listening on port 80 across the board. If I wanted to use 2 different ingress controllers, I'd have to have them listening on different ports, and I'd have to have a load balancer in front of it. So traffic to one site ends up in the load balancer, and it ends up sending it to the correct port for the Nginx routing, and we continue off from there. And in that case, I would tell the backend stuff what to listen to, or like what I would tell the ingress. I'm sorry, I'm not answering this well. I would tell the ingress controller which backends are participating, and if it received traffic for something that's not in what it's participating, it would just return a 404.
Okay. Okay, cool. Let's see. I'm trying to find. There's quite a few questions about Rancher and also Kubernetes. So I'm just looking for the Kubernetes question.
We can do this for like 2 more minutes, and then I should jump into Rancher so we leave enough time.
Sure. You mentioned this before, but I think people missed it. Is the KC command an alias of kubectl? Yes.
I'm just too lazy to type kubectl because I type it all the time.
Awesome. Okay, one more on Kubernetes. This was from earlier in the session when we were talking about replica sets. Is it possible to get an SQL replicas? This is from Christopher.
Yes. What you're looking for there is a stateful set. And so stateful set, you would have, so in your traditional MySQL master-slave deployment, you have your masters and you have your read-only replicas. And the problem was always, well, you have to maintain either 2 data sources, one for read and one for read-write, and it was a big pain. There are a couple solutions that have solved that. One that works very well with Kubernetes is called Percona. And Percona is essentially multi-master MySQL. And I'm just talking about MySQL or MariaDB or whatever because I can, but the same concept applies to Redis or Mongo or anything else that needs to keep track of state. Percona works because it's multi-master. So every single member of the stateful set is essentially a master, and so that allows you to send traffic to any of them, and they'll handle getting it where it needs to go. It works similar to how Redis and Mongo work, where you can send traffic to any one of them, and they know who the master is to actually write the data out.
Okay. Okay, one more, and then we'll move on to the Rancher stuff. That work?
Roger that.
Okay, cool. So this is from Russ, who says, so it seems to me that the ingress controller is a single point of failure. If that crashes, then what?
The ingress controller. It's not actually a single point of failure. Oh, hey, look at that. Node lost. That's interesting. It's not a single point of failure, and this actually makes for a really good demonstration. I have 3 nodes. So there is a pod that's called the default HTTP backend. It essentially returns a 404 for anything. It's like traffic that Nginx doesn't know how to route ends up there, and it just says 404. In this case, there's one ingress controller running on each of my 3 nodes. In this case, one of them appears to be dead. So that node is not receiving any traffic, or at least Kubernetes doesn't think it is. And because I have a load balancer sitting in front of these, I have HA proxy sitting in front of it that's doing health checking on the nodes itself. HA proxy would have failed that node. So HA proxy will only be sending traffic to those 2 nodes, and there's no single point of failure. The Nginx ingress controller, you can configure it to be a deployment or a daemon set. I configure it to be a daemon set so that it's listening on every single node. But certainly if you had 1,000 nodes, you don't necessarily need all 1,000 of them listening on port 80 for your traffic. In which case you can set it as a deployment, and you set the number of replicas, and then you define where you want those deployed, and then you put a load balancer in front of those.
Awesome. Okay, cool. Well, there's more questions, but why don't you keep going with the demo, and then we'll get to them after.
Okay. I'm going to nuke that pod. All right, so we're going to move on to Rancher land. Oh, config maps. Before I go into Rancher, if you want to learn more about microservices and building distributed systems within Kubernetes, this book will give you a good start. Its author, Brendan Burns, worked at, or possibly still works at, Azure as the director of engineering. Now, the reviews on Amazon are hit or miss, and I have not personally read it, but the general consensus is that it's a good primer for helping you understand concepts and giving you enough information to decide where to go next. Also, as you are no doubt aware, there are literally a bajillion web pages out there with information, and I think bajillion is a real number. And I recommend that you follow a strategy similar to what my 5th grade teacher taught me about reading documentation, though at the time it was just about reading any type of instructions. Instead, if you don't understand it, just read it again. If you still don't understand it, just read it again. And eventually, it'll make sense. You may not believe me, but it works. But in all cases, I recommend that you peruse the Kubernetes documentation available at kubernetes.io. Those docs are excellent. And then for Rancher-specific stuff, we also have a lot of documentation and tutorials on our website. So let's talk about Rancher. I have no more slides. That's cool. It's just demo. Since it's just demo, I'll make my browser really large. Woo. Actually, I won't, because there's still some commands that we need to use. It's still stuck. That's interesting. Huh. I'll deal with that later. Okay. I have 2 brand new nodes here in my house. One's going to be a server, and one is going to be a single node Kubernetes cluster. To run the Rancher server, there's a few ways you can do it. One is you can just run it as a standalone container. And this is fine if you just want to play around with it. But when we say don't do this in production, we're serious. Don't do this in production. It's a single container. If it dies, it's bad. If you think that you might want to put real workloads in here, or that you might promote this to a production server cluster in the future, but you don't want to dedicate 3 nodes to make a full HA Kubernetes installation, you can install RKE on a single node. RKE is Rancher Kubernetes Engine. It's our Kubernetes distribution. It's super lightweight. It runs everything inside of Docker containers, and it's actually how we'll be deploying Kubernetes in a second. If you go to the Rancher docs, if you go to the Rancher docs and you go to Rancher 2 and you go to installation, and it talks about single node or HA. Single node is the Docker container node version, whatever. That's how we're going to do it today. HA walks you through deploying Kubernetes onto 3 nodes using RKE. You can do these exact same instructions with a single node. It's obviously not HA, but RKE is awesome in that later on you can just add 2 more nodes and it'll just deploy 2 more etcd containers, replicate all your data, and Bob's your uncle. You've got HA Kubernetes. For today, we're just going to deploy the container. You ever tried to talk and type at the same time? Can't do it.
Occasionally, but no. Try to avoid it.
Can't talk typing. Okay. Docker run, daemon, restart is unless stopped. We're going to open 2 ports. And this particular thing is not actually in our documentation, but I recommend that you do it. What this does is it mounts a volume from the disk into the container itself. The reason you want to do this, if you're just doing this is only necessary in the single container mode. The reason you want to do this is because if you deploy it as a standalone container and then you nuke the container, you lose all your data. So don't do that. And then what we want to run. Remember I told you earlier, you don't want to run latest, even though our documentation tells you to. I'm going to tell you not to. Run a specific version. There are 2 versions available with Rancher. There's latest, which is bleeding edge, never run it in production. And then there is stable. Stable is, so when we do releases, we'll release, for now, for example, we're on 2.1.5. So when 2.1.6 comes out, it's going to be latest. And then after it sits out there for a couple of weeks and people run it and we make sure that it doesn't have any bugs or whatever, it'll be promoted to stable. But maybe there's an issue and we release 2.1.7 and stable is still 2.1.5. Stable has been tested, vetted, used by the community. It's baked for a little while out in the wild. So that's always your best bet, unless you need some new bleeding edge feature that you want to test, in which case latest is the way to go. By now, I should have the server up. Just came up with default self-signed certificates, so I have to accept that little warning that says if I log onto this site, my universe will end. And here we are. This is a Rancher server. Before I walk you through all the global stuff and things like that, I'm going to go ahead and deploy a cluster. And then while that's deploying, I'll take you through some of the global options. For that, let's log into training-A. Wait for my phone to send my private key. Which usually doesn't take this long. That app is a cool app called Krypton. You run it on your phone, and it pulls your private key off of your actual host. So even if you're using passphrases and whatnot on your, why are you not working? Even if you're using passphrases on your SSH keys, this is great because it moves SSH easily into the land of 2-factor authentication by moving your private key to your phone, which you can then authenticate with Touch ID or whatever. It has a dependency on Amazon SQS, which apparently is not working. You guys still with me, or did I lose internet?
No, we hear you. You're good.
Okay. All right. So there's something wrong with Amazon. All right, cool. I want to make sure I wasn't talking in the dark.
No, you're good.
All right. So over here, this is a empty brand new VM, and I'm going to say add cluster. Now Rancher will deploy into hosted Kubernetes providers. So in this case, GKE, EKS, AKS, and we're going to add more of these in the future. DigitalOcean's new service is awesome. I'm actually moving all of my stuff over to it. So you just provide the credentials and we'll reach out there and provision the Kubernetes cluster for you and then start communicating with it. If you want to run on infrastructure, you can choose EC2, Azure, DO, or there's actually a whole bunch of other node drivers here, including you can add your own. And so what we'll do in that case is we'll reach out to EC2, for example, and we'll spin up the nodes as you've defined them here, and then we'll SSH into them, install Docker, deploy RKE, and then bring them back into the Rancher cluster for management. If you've got vSphere in-house, cool, deploy it there. If you are running an existing Kubernetes cluster out in the wild, we can import it, and that's great too. So for example, if you want to use DigitalOcean's Kubernetes service, you can just go launch it in DO, since we don't have the thing here yet because it's not GA. You can go launch it in DigitalOcean and then choose to import it into Rancher and manage it from within Rancher. Or anything that doesn't fit one of the above examples, you can just do a custom install. And custom will give you a Docker command to go and run on your hosts. There's some stuff here that you can set for cluster options like project network isolation. I wrote an article a few days ago in response to the Cloud Native Computing Foundation's 9 things you should do to secure your Kubernetes cluster, where I said that 9 things is not enough. And I pointed to Rancher's server hardening guide, which has more than 110 things that you can do to secure your Kubernetes environment from outside attack. In that article, I talk about project network isolation. So please go read the article. Love to have feedback on it. And if you want to turn that on, that's here. Today, I'm going to leave that off. If we were running in a cloud provider, here's where we would set that. Get more information here. There's also various advanced cluster options that you can set related to node ports, metrics, pod security policies, and a whole host of things around snapshots of etcd and such. Also, here's where you can find the latest versions of Rancher that have been tested and deployed. We'll just say next, and this is going to ask me what roles I want this node to have. Since I'm deploying a single node, it needs to be an etcd and a master and a worker. And it gives me this Docker run command down here that I can run. We're going to run that. And while it's thinking about its life, I will tell you more about this command. This command is unique to the cluster that we are creating. What that means is you can take this and you can bundle it in with any provisioning or configuration management system that you use, whether that's Cloud Config at Amazon, Ansible, Puppet, Chef, Terraform, whatever. However you launch nodes, if you don't want to do it directly from within Rancher, you can just pop this into here. And you can see, for example, the etcd and control plane and worker settings are just flags. So if you if you had a EC2 auto-scaling group, for example, that would scale up your workers in response to system load or scale them back down, just drop this into Cloud Config. And when the auto-scaling group adds more workers, they'll just join the cluster. You don't have to do anything. You could just sleep and go on vacation or do whatever. Here you see the cluster is being built, and it's going to start talking about stuff. This will take a few minutes to do. So while it's doing it, I will talk about some of the global options that we have. The first one is authentication. The first key benefit that Rancher provides is that it plugs into whatever backend authentication system you want to talk to, whether that's Active Directory, Azure AD, GitHub, SAML, OpenID, all of it's here. Or you can just use Rancher's own local database if you want. If you plug it in, we immediately bring in all your users and groups, and we make those available for you to assign them to roles, and then you assign roles to clusters, all of the clusters. So you might have within your organization teams on different clusters. And the problem is, if you try to build these things manually, you try to manage this on your own, imagine you've got one team that's using GKE, one team that's got a cluster stood up on EC2, another one that's using Azure, another one that's using EKS, and then suddenly somebody leaves the organization. You are in the business now of managing access credentials to each of these different providers, IAM accounts or Azure accounts or Google accounts or whatever, and I guarantee you eventually somebody's going to leave and you're going to forget to disable their account. When you plug Rancher into a backend auth system, Rancher becomes the authentication proxy to all of the clusters. People talk to Rancher and it proxies everything through to the destination cluster according to the permissions that the user has. Now, if somebody leaves the organization, you just disable their account in Active Directory, and immediately they lose access to every single cluster that they might have been able to talk to before. Here's where you would define roles. So you can create, we ship some defaults. There are roles at the global and the cluster and the project level. So you can create new roles, and you see there's all sorts of things here about what people are and are not allowed to do. And you can inherit from roles. You can do all sorts of cool stuff. And then within users, here's where you would have local users, or where you would see any of your backend authentication providers users. Rancher has an application catalog, which you'll see in a second. We ship with what we call the library, which is a small list of curated Helm charts, and we're not providing support for them, except for the ones that either that we say are ours, but we've at least vetted them enough to say that they work well enough and they're not likely to break your stuff. You can also import the Helm stable repository, the Helm incubator repository, or you can add any external Helm repository that you wish, and their applications will become available within the application catalog. Our cluster is now ready. So you see up here, we have cluster, called it training, and we have two projects. Projects are a collection of namespaces. Namespaces are a Kubernetes thing. Namespaces are a logical grouping of stuff. So because names have to be unique in Kubernetes, you can only have one deployment called website in a particular namespace. You can't have another one called website because Kubernetes doesn't know what you're talking about. So you would create a namespace, usually per application or per logical group of things, and then you can assign role-based access control to those namespaces. But that also becomes a burden to manage. Imagine if you have a development team and you need to now manage access to 400 different namespaces for each of the projects that they're working on. No bueno. Instead, create a project. Under that project, so let's just add a project and we'll call it training. Here, you can start adding members and designating which role they have. Earlier, I was showing you various roles at the project level. You can also define project-based resource quotas. So I could say every single application or pod or anything running under this project, if you bundle it together, cannot consume more than 2 CPU cores, period. And it cannot, so namespace default limit. So you can set resource quotas here for CPU, memory reservations. You can also say, for example, a reservation of I want to reserve 1 CPU core for this project, so nobody else is going to be able to use it. Let me delete these so I don't screw up my demo here. If we create a new project, now you see down here we have the training project, and under there, let's just create a new namespace called training. Let's say create. You see now that it shows up down here as a project. And when I select it, now we're in a project. We have workloads, load balancing, service discovery, volumes, and pipelines. You're going to spend most of your time under workloads. Before I get into that, though, let me jump back out to the cluster. And there was a question about kube control and how I'm talking via kube control, doing stuff that gentleman thought I could only do during the UI. That person, I'm sorry, I may be remembering your name wrong, but that person thought I could only do during the UI. So there's a couple of things you can do here. One is you can say, give me the kube config file for this cluster for me. And you will see in the server line that it's actually talking to training-s, which is the Rancher server. The Rancher server proxies everything. So you connect the Rancher server with kube control. It handles all of the RBAC stuff for the cluster that you're trying to talk to. And then if you're allowed to, it proxies all your communication down to that cluster. So that's how that works. If you don't want to run kube control locally on your machine, we also give you this really cool, pause. We give you this cool shell, where you can run one-off kube control commands directly here within the UI. So I'll jump back down to training, and we will do a deployment. When you do a deployment, everything that you would set up in a Kubernetes manifest is available for you here. So I'm going to call this Hello Rancher. What type do I want it to be? Well, by default, it's a deployment of one pod, but I can make it a daemon set, a stateful set, a cron job, or a standard job. What image do I want it to be? I'm going to run Superseb's Rancher demo. He's one of our support engineers. He is amazing. Because I'm in the training project, I only have one namespace available to me, and that's the training namespace. If I add a port here, Rancher will automatically create a service for me, because if I'm going to create a port or expose a port on the pod, obviously I need a service, so it doesn't make me do additional work. I think his container listens on port 80. We'll figure it out in a second. Cluster IP, same as container port. And you start getting into this whole range of things that you can configure: health checks, storage volumes. Up here we have config maps and secrets if you want to store API keys or passwords securely inside of the Rancher environment, but mount them inside of Kubernetes workloads so that they can do stuff. Logging, there's all sorts of stuff here. So for example, I could use a config map, or I could mount a secret, or I could use a certificate and mount those things as volumes. And then there's also advanced options, just in case you wanted more decisions. You can change the command, you can control networking options. Here's where you would set up your labels and annotations for the person who asked about the multiple ingress thing. Here's where you would define that. And then various things about the security of how it's being deployed, memory reservations. Trying to build all of this as Kubernetes YAML it's going to take forever to do. Doing it via the UI is lightning fast. And I also like to point out that if you are new in your Kubernetes adventure, deploying Rancher is great. Like, everything that I'm about to deploy, we can then go interact with via kube control. So if you want to get stuff up and running and actually get some workloads out there that you can look at and play with and poke at and figure out and use to learn Kubernetes, this is hands down the friendliest way to do it. So we got Rancher demo, namespace training, cluster IP service. I didn't change anything else. Hello Rancher, we're going to launch. And it's going to go and it's going to do its thing. It's going to pull it down. Out here under service discovery, you see that it created the service for me because that was super easy. If I wanted to add volumes, we can define persistent volumes directly, or we can also do under storage at the cluster level. You can also set up storage classes. Persistent volumes are persistent volumes. They are a specific thing. Here is an NFS mount. Here is an iSCSI volume. And then you use a persistent volume claim to attach that persistent volume to a particular workload. Storage classes are super cool. What a storage class does is you define what's called a provisioner inside of the cluster. And a provisioner knows how to provision storage. It knows how to make EBS volumes. It knows how to allocate NFS volumes. It knows how to allocate iSCSI storage. And then your workloads simply say, hey, I need some storage. And they ask a particular storage class for some storage. And then the storage class provisioner provisions that storage, gets the persistent volume, and hands it back to the workload. And so now you don't have to be a bottleneck of creating storage. People in your organization can create the storage that they need when they need it, and you can set all of the parameters about how they're allowed to do that. That's storage classes. That's out there. We jump back into training. By now, we have our workload. That's cool. And so we want to talk to it. So we're going to add an ingress. Once again, we're in the training namespace because that's the only namespace under this project. We're going to create an xip.io hostname. xip.io is this slick service where anything that you give it as an ip.whatever.xip.io, it just returns the address. So if you want to start building applications and testing them locally without you having to go and create DNS records, or maybe whatever, all of this, any of you have ever done anything related to DNS stuff when building apps, if you haven't seen xip.io, it's great. So we're going to automatically generate an xip.io hostname because we're testing. And I'm going to send traffic to a service. I'm going to send it to the Hello Rancher service. Here's where I could add additional, here's where I could add additional paths like we did earlier to the ingress. I could send it to something else. Or I could even have different rules for different stuff. So if you want to create one ingress for all of the domains that you run on your site, you can do that. It's super flexible. Remove this rule. If you load SSL certificates into here, then you can attach them. We also have hooks into Cert Manager, so you can dynamically deploy Let's Encrypt certificates by adding some annotations to your ingress here, and it'll go out and provision a Let's Encrypt certificate, load it into Rancher, attach it to your ingress, and then automatically renew it every 90 days. It's amazing. I'm getting very excited. Running out of time. All right, we're launching Ingress. This will take a second to go and get the xip.io hostname, and in a moment it will appear here. While it's doing that, I'll just point out a couple other things. We had volumes. If you don't currently have a CI/CD system, if you're not using Jenkins or GitLab, whatever they have, Drone or Travis or GitLab CI or whatever, but you have your stuff in repos and you want to start doing continuous integration and continuous development, where when you push code, it automatically updates running workloads within your Kubernetes cluster. We ship with a small, very simple pipeline engine. So you can get started with that right now. Provision your repositories and start doing pipeline work. By now, we should have, yes. Oh, bad gateway. This happened in an earlier training. Let's jump back to, I think it just takes it a minute for the ingress to build its stuff, but we'll take this opportunity to do a little bit of troubleshooting. I'm gonna launch kube control. I'm gonna get the ingress. Oh, we need to be in the training namespace. Okay, 10.68.0.143. That should work. Let's see if it works now. Fail. Huh. I'm gonna have to revisit this. Well, let's change it so that I can show you this really cool container that Superset built. Training, load balancing, edit. I'm going to specify a host name, and this host name is going to be ring-a.cl.bannock.us. We're going to say save. Spell that gateway. Oh, I know why. Remember I wasn't sure about the container port? That it's 8080. All right, let's try this again. Okay, 503. You're gonna make me go back to my Nginx deployment here. All right, give me a moment to troubleshoot here. Let's go figure out what I've done wrong. Make sure demo. Docker file 8080. So let's come back out here, go to my service, edit my service. It's a really cool container. Let's try P. Ingress is pointing to the wrong port. No, it's pointing to the right port. Okay, well, I'm not going to continue to troubleshoot this. Apparently, I screwed something up in demonstrating this, but I assure you it does work. To get out of it elegantly, I'm simply going to come in here. I'm going to show you that you can edit anything that was running previously. And so I'm going to change this to 1-15, 1.15-Alpine. And we're going to upgrade that workload. And it will go and it will fetch and it will do what it's going to do. Other things that you can do in here include things like executing a shell within the container itself, so you don't have to go and find what container something's running on. And now we should have, let's edit. That's actually 80. Great. All right. And now if I come back out here, we get the very much not exciting, oh, we get the default backend. That's also not exciting. All right, I'm going to stop there because I'm not doing a very good job of demonstrating to you how to do an ingress properly because my notes are bad. We're almost out of time, so I want to stop the demo and go to questions so I can show you stuff. What do we got, Matthew?
Cool. Awesome, Adrian. Okay, let's get into questions. This is from Hytham, who says, can you upgrade a Kubernetes cluster like RKE or GKE using the UI of Rancher server?
Can you upgrade a cluster RKE or GKE using the UI of Rancher server? I don't actually know. Please make a note of that. We will get you an answer to that. I don't know if we can do the upgrades of it or if seems like we should be able to, but I'll find out and I'll get you an answer. Matthew, can you please make a note?
Cool. Yep, sure. Okay, here's the next one from Nikos, who said, is a workload a pod?
So a workload is either a deployment, stateful set, daemon set, job, or cron job. It represents the unit which you are going to be working with. And then under that, it will create other resources, replica sets, pods, things like that.
Okay. Awesome. Okay, here's one from Greg, who said, so this is a little opinionated and basically ties together why to use Rancher over Kubernetes. How do you know what goes into it? He says, our architects said not to use Rancher and to only use Kubernetes. What's your view? Kind of opinionated, so.
It's kind of opinionated. There's also not really a lot of information there. Your architect
Yeah.
said don't use Rancher and only use Kubernetes. What's my view? Well, I would love to know more about why they said that. I guarantee you that you have more risk, more headache, more management overhead, more difficulty doing upgrades, more problems with zero downtime upgrades. Like if you are just using Kubernetes, you're doing 5 times more work than you need to. If you want to find me on Slack, my name is Adrian, and like I said, I'd love to know more about why they said that, and maybe I can help change your mind.
Awesome. Super great. Okay, cool. Next one's from William, who says, does Rancher do monitoring also?
Yes, Rancher does. As you can see, I got this up and running. I was using the wrong URL. It's the Nginx page, so I feel less a fool. But let me show you that Rancher does monitoring. So we've got the cluster, and out here under Tools, you can set up alerts. And at the moment, so we're running 2.1.5 stable. With 2.2, which has a beta coming out on 5th of February, there will be additional monitoring enabled in here. Obviously, it's a beta. Don't run it in production, but the GA release will come shortly thereafter. I can't tell you what's coming, but I can tell you that it's a lot more extensive and you can do a lot more with it. Right now, we will monitor and send alerts for all sorts of things here. So you can add alerts based on scheduler or what system service isn't working right. You can set thresholds. You can do some other stuff, and then obviously within the cluster itself, you can set any kind of health checking on your workloads themselves that control that. That's just Kubernetes. So yes, Rancher does also monitor the Kubernetes cluster and can notify you if it needs attention.
Awesome. I'll just add that in December, our online meetup, Jason Van Brackle and Bill Maxwell kind of showcased a lot of those new features that are coming out too. So if you want to check that out, it's another video.
And there you go.
All right, the next one from Russ. He says, buzzword, serverless lambdas. Is Rancher working towards adding serverless execution?
Oh, hello. Is that Russ? Is that what you said?
Russ, yes.
Hi, Russ. My name's Adrian. Whoops. Can't talk and type. It's my home cluster, the one that we were using earlier. And I would like to introduce you to. Okay, so here's OpenFast. This is a serverless architecture. You can also run Knative. You can, whatever. There's a ton of serverless stuff that runs within Kubernetes, and you can run all of it within Rancher. So I run, as you see, some of these are just like playing around, but in my production cluster out of DigitalOcean, I run serverless workloads that do various things for automation for Rancher as part of my job, and I love serverless. I will go one step further and tell you that if you are interested in abstracting away the entire Kubernetes layer. Now, obviously, serverless isn't actually serverless. Somebody's got servers and somebody's running them. So a serverless Kubernetes solution is not actually serverless or not Kubernetes. But if you want to abstract that away to give your users or yourself the ability to do things super easily, take a look at Rio. Rio is something that we have in development right now, but because everything we do is open source, you can pull this down, you can start to play with it. It is serverless Kubernetes.
Sweet. Okay, awesome. All right, let's go to the next one. Murad asks, what's the best practice for upgrading Rancher?
Okay, that's a good question. In our documentation, we cover all that here in how to do upgrades and how to do rollbacks. So this is how to upgrade if you're doing a single node install. If you're working in an air-gapped environment, we do also support full air-gap. Ranchers deployed inside of banks and financial companies and governments and military installations all around the world. So air-gap's a big part of that. Or if you're doing an upgrade of an HA environment, the process is essentially you make a backup, and then you just update the Rancher server image, and then the next time the agents connect to it, they all do an upgrade of themselves, and then any additional components also get upgraded. Upgrades are zero downtime, so you don't have to reboot. Workloads will continue to run just fine. Just the supporting infrastructure will do a rolling update across the cluster. And then we also support rollbacks. So in the event that something goes wrong, you can roll back to the previous version and undo everything that you just did. For RKE, it's similar. RKE is our Kubernetes engine, and RKE you can use by yourself. If you just want a really easy way to deploy Kubernetes, check out RKE. If you want a really easy way to manage Kubernetes clusters from anywhere, check out Rancher. They also work really well together, but there's no dependency. So with RKE, you simply change in the config file the version. So if you're doing this manually, you would change the version here, and then you would do RKE up, and it would do a zero downtime upgrade of your RKE cluster. If you have an RKE cluster, global, and there's a new version that you want to change to, then you can simply come out here and after updating the server, so let's say that we're running 2.1.10 now, and there's a new supported release of Kubernetes that we have in there. After updating the server, you would come into your clusters and you would do an upgrade to whatever the next version of Kubernetes is that you want to run, and it'll do a zero downtime upgrade of your clusters.
Awesome. Thanks, Adrian. Okay, here's the next one. How do we use the built-in library on air-gapped networks?
I didn't even show you the library. I'm such a bad demoer. Shame on me. Okay, well, in order to answer that, I must show you the catalog. I briefly touched on catalog, that this is the library, and these are the curated Helm charts that we ship with, where we can say, yeah, you can go and you can deploy WordPress. These differ slightly from regular Helm charts in that so with Helm you have values.yaml, and you basically put key value pairs or your YAML for nested stuff to define things that control how the Helm chart is deployed. The Rancher app catalog, for the stuff that we've got in the library, turns those key value pairs into a really nice question and answer form, and then that generates values.yaml from the data, and then Helm, we apply that with Helm. If you are building Helm charts, you can also make them into app catalog sexiness like this. There's instructions for how to do that on our website, where you can have your own private app catalog repos for whatever your applications are. But if you just wanted to use regular Helm charts, let's go catalog apps, and you'll see, for example, here's OpenFast. You can just put the key value pairs in here if you know what they are. To get back to the guy's question, though, if you have an air-gapped network and you wish to use, well, so if you have an air-gapped network, it's not just the catalog that's going to be an issue. You need to either whitelist some stuff that we talked to if you're in a corporate network that's not air-gapped. Otherwise, if you're doing a single node install, you are going to need to have a private registry inside of your air-gapped environment, and you're going to need to go in there with a laptop or something that has the images, and then you're going to push those images into the private registry. You then would adjust where Rancher is going to look for things to make sure that that it's able to find them in your private registry. Right here, configure Rancher for the private registry, instead of trying to go out to the internet to get stuff. And then it's just fine. The app catalog, elements and charts. Yeah, we don't have documentation on doing that in here, but because the app catalog is simply a Git repository that has stuff in there of a specific format, you could theoretically clone the repo and then just do a bulk search and replace to replace where those things are coming from and put your private registry in there as the source registry. And then you would still be responsible for pulling those images down, taking them into your air-gapped environment, and pushing them into your private registry to make them available. Or if you have your own applications within the catalog that you're using, you would follow more or less the same steps.
Awesome. Okay, amazing. So there's a few more questions on clusters. Next one is, how do you remove a cluster from Rancher?
Oh, you come out here and you say delete.
Awesome.
And then it's gone.
That's my favorite answer. Okay, cool. Let's see. Next one. Can you import an existing Kubernetes cluster installed at an on-premise data center, and how?
Yes. You say add cluster, you say import. And unfortunately, I can't import the cluster that we just are using because it already is wired up for Rancher. But once you say that you want to import a cluster, we give you a kubectl apply command, and you go run this against that cluster, or this one if your Rancher server is using self-signed certificates. And this will install, it'll create some namespaces inside of your Kubernetes cluster. It'll install the Rancher agents, and then the Rancher agents bridge between the Kubernetes API and the Rancher server. And it's easy. It takes seconds to do.
So good. Sweet. Okay, here's the next one is from Alexi. Can you choose what CNI plugin to use for a new Kubernetes cluster?
You can. Give me just a second here to roll back to a snapshot on the training cluster in case I need to get back to
Sure.
it, since I just nuked it. Okay. Uh, can you choose which CNI plugin to use? Yes. Let's say done. That's pending. Let's delete that. Delete. We're going to say add cluster, custom, and cluster options. There you go. So we got Flannel, Calico, and Canal. Those are the ones that we have tested and that we include in our SLA. You will find that Rancher, while it gives you tremendous amounts of freedom, you might say, oh, I want to use XYZ CNI provider. How can I do that? Well, Rancher sells support contracts, and our support contracts cover the Docker engine, all of our stuff, and all of Kubernetes. So we have an extensive testing process for new Kubernetes releases, for CNI plugins, for stuff, because we're on the hook if any of this stuff breaks. So if you wanted to use a different provider from this, there are ways that you can configure that manually. So, for example, you'd use RKE and you would just deploy your RKE cluster yourself, or you could deploy any other Kubernetes cluster and then import it into Rancher. We just don't list all of those here because they haven't gone through, or in some cases haven't passed, our rigorous testing procedure. These
Awesome.
guys all work great though. Flannel is super easy to use, very friendly, and you see that it includes Windows support. Calico uses BGP for routing between nodes. It also supports network policies. And then Canal is like a hybrid between Flannel and Calico, where you get the ease of Flannel and then the security of Calico with network policies. And it's with Canal that you get project network isolation. And what that means is that if you have multiple teams working on different projects, the workloads running in project A cannot speak to the workloads running in project B. So it's full on isolation, not just of the users only being able to see their project, but the projects themselves only being able to see what lives inside of their project. That's only available with Kate.
Cool. Okay, next one is from Diogo, who says, does there exist an integration between F5, Big IP, and Rancher?
Yes. Sorry, I had to pause. I was blowing my nose. Um, you guys don't want to hear that. Yes, there does. Let's see if we have it out here. No, it's not there. So the integration between F5, it's not actually an integration between F5 and Rancher. It's an integration between F5 and Kubernetes. And F5 has an ingress controller that will communicate with their external stuff. And essentially what it does is when you create, well, I don't know exactly how it works, but when you either create an ingress or when you create a service type load balancer, it picks that up and reaches out and provisions an F5 load balancer for you. I know that in early, like a year and a half ago, there were some issues with the level of control that they wanted over Kubernetes. Hopefully they've fixed that now, but that still has nothing to do with Rancher. So it doesn't matter to us what you want to deploy. If, for example, F5 shipped you the YAML for their ingress controller, you would just go out to kubectl and run kubectl apply, ta-da, and you'd get your F5 agents running inside the cluster.
Awesome. Okay, here's the next one from Anil, who says, can you show the logging features in Rancher and how they work?
Yes. It made me delete my cluster, so I'm over here now. Oh, I in fact have logging enabled. That's pretty sexy. I'd forgotten that I turned that on. So this is my production home cluster because everybody needs to run a Kubernetes cluster in their house, especially when you want to test things like serverless or when you just want a really reliable way to run Plex, which I do. I also run home automation stuff. I have a bunch of cool stuff that runs inside of my cluster. Outside of my cluster, I run a 2-node Elasticsearch cluster, and I've configured the cluster to send all of the logs to it. You can provision authentication here, and you can provision how you want stuff to be built, additional custom logging fields, and so on and so forth. The result of this is, I jumped over to Kibana, all all of the container output, all of the logs that come out on standard out and standard error. No, it's just there. There we go. Level dash star. Get logged to Elasticsearch. So, for example, here's, I don't know, who is this? C-store pool management. So this is the OpenEBS container is complaining about something not being reachable, which is interesting. I think it's because one of my nodes is misbehaving right now. But then you're free to do whatever you want with this. If you don't want to send it directly to Elasticsearch, you can send it via syslog to Logstash and filter it, and then send it into Elasticsearch. Or you can send it to Splunk or Kafka or Fluentd or wherever you like. We also, before you jump to the next question, Matthew, we also have integrations with apps, launch. This isn't really logging, but we have Sysdig. So there are, you can deploy those directly from the catalog. And we also have Datadog. You can deploy that. And then it's like logs.io and stuff like that. If there's anything that isn't already in the library, logs, yeah, that's not there. Then these people probably have their own Helm charts. And so you can also just deploy, if you use like logs.io, you can just deploy their agents inside the cluster and it'll do whatever it needs to do to ship those logs out to somewhere else.
Super cool. Awesome. Okay, cool. Next one is there any way to see and edit the YAML files except through the command line?
Yes. So you see here, I'm on the workloads page, and I was just kind of demonstrating that you can also get the individual container logs, or you can execute a shell directly on a container. But also over here, I can say, show me the YAML. It's like, show me the money. What was that movie? Something McGuire, Jerry Maguire.
Yeah, Jerry Maguire.
So show me the YAML. Show me the YAML. So here's the YAML, and this is just like running kube control edit over here. I can change this. What did I make here? It's interesting. Why do I have both of those? So let's, whoops, that's not what I want to do. Oh, because we're not in the test cluster because I deleted it. View edit YAML. So I could, for example, come down here and change the image to Nginx 1.14-Alpine and say apply. And it's the same as if I did a kubectl edit or kubectl apply-f, whatever. You see it'll do a rolling update of the workloads.
Oh, amazing. Okay, sweet. So, all right, the next one is from Chris. You might need some more info to answer this question, Adrian, but he says, how many pods per node have you been successful with based on bare metal nodes?
That's a function of how big the node is. If you've got something that's got 1 core and 2 gigs of RAM, and you try running, a bunch of big resource-heavy pods on it, it's not going to handle very many. Versus if you've got, whatever they have now, M10 or M4 10XLs, or what. I did work with a customer whose name I can't say, but they might be the largest Amazon spender, and this guy's like, all right, let me just spin up this like 32 core, 256 gigabyte of RAM system, and then we'll get 10 more of them. We'll just start playing with it. Ridiculous. Those things obviously can run a lot. There are limitations within Kubernetes. So this is funny. Kubernetes by default wants you to run less than 100 pods per node, but that's not a hard limit. You can run whatever you can run. If any of you have seen Spinal Tap, if you remember the scene where the volume knob goes to 11, well, Rancher's pods go to 110 per node. But it's still not a hard limit. It's really a function of what those pods are doing.
Okay. All right, cool. Next one is from Noah, who says, are there any recommendations for the OS of the Rancher node? Why use Ubuntu and why 16.04?
I use Ubuntu 16.04 because I don't like Ubuntu 18.04 because they changed a bunch of the networking stuff and it super annoys me. And 16.04 is still in long-term support, so I just keep running 16.04. I also have extensive Ansible configurations that are built around 16.04, and I'm doing too much to justify the time to fix it just to roll to Ubuntu 18.04. But that's me. Rancher will run, well, Rancher and RKE will run on any Linux operating system or Windows in some case, but Windows support is still experimental. I make fun of Windows because it's still experimental. Sometimes it works and sometimes it doesn't. But I guarantee you, with Windows Server 2019, they're going to have Kubernetes running native. So it's coming. But for right now, we're talking about Linux nodes. Anything that runs Docker. So that's it. We have no requirements whatsoever. And in fact, we also have our own operating system called Rancher OS, which also is not a requirement, just like RKE is not a requirement for Rancher. Rancher OS is not a requirement for anything. But this is a super lightweight operating system that runs everything as Docker containers. All system services, there's System Docker, which runs all system services as containers, and then there's a user space Docker. This thing is lightweight, very, very popular with our VMware community and bare metal community. You can deploy droplets on DigitalOcean with Rancher OS, and it works really well. So yeah, if you can run Docker on it, you can run Rancher on it.
Sweet. Okay, on that note, Nikos asks, do you have a GitHub repo demonstrating RKE without the Rancher UI? Alternatively, what kinds should we extract to make sure that we can reproduce everything in case we completely lose our HA?
Okay, let's take the first part of that. Is there a GitHub repo that shows doing stuff with RKE without the UI? For that, you want to come out to our docs and go to RKE, and everything out here talks to you about how to do stuff with RKE via its configuration file, which looks that's the old one. There. So that's a basic RKE config file for the 3-node cluster that you guys have seen me working on right now, which tells it how to talk to it, what SSH key, etcd snapshots, and some feature gates stuff for some more advanced. It's not relevant. So that's your source of doing all things RKE without Rancher. The second question was what? The second part of that?
Yeah, he says, alternatively, what kinds, and kinds is in quotes, should we extract to make sure that we can reproduce everything in case we completely lose our HA?
Okay, I'm not sure what you mean by kinds, but I'll tell you what you need to do in case you lose your HA. On each of your nodes, you're going to want to mount some kind of shared storage. Backups and disaster recovery. They moved its destination, but there's a path. It's like varlib rancher or varlib etcd snapshots or something like that. And you're going to mount some kind of hello Cloudflare. Don't like Cloudflare either. Okay, well, so my Cloudflare node in Santiago is not working. Let's see if I have this on my nodes. Well, that's logging in. Look here and see etcd snapshot true, creation every 6 hours, retention 24 hours. And on this node, you see that I've mounted some shared storage from my local NFS environment to opt RKE etcd snapshots. And what this does is this creates a backup of etcd every 6 hours with retention of 24 hours. And you can control that. You can do it every 5 minutes if you want. With one of these, you can restore your Kubernetes cluster anywhere in the world. So if the documentation page was working, there we go. So in addition to snapshots, we also talked to you about how to do etcd disaster recovery. Everything about your Kubernetes cluster is stored in etcd. And in fact, if you deploy Rancher and HA inside of RKE, everything about Rancher is stored in etcd. So you really want to have these backups in place. You can then redeploy Rancher, reload etcd, get your whole cluster back. Obviously not the data itself. You're responsible for having backups of your data, but everything related to the cluster, every pod, workload, deployment, stateful set, configuration, RBAC, all of it is inside of these backups.
Okay, sweet. This is sort of actually a follow-up question. There's a few more, Adrian, so you kind of know where the queue is at. Um, Nikolai asks, if the Rancher server dies for some reason, the Kubernetes clusters are kept alive, but there doesn't seem to be any direct access to them. So as far as I know, there's only one possible solution to keep the Kubernetes clusters, which is to deploy a new Rancher server and initiate the connection from the existing Rancher agent. Is this the only solution, or am I missing something?
At the moment, you're absolutely correct. Because the Rancher server proxies, hang on, I'm going to sneeze. I'll put my finger over the mute button here.
Okay.
If the Rancher server, okay, so the Rancher server is the authentication proxy to all of the downstream clusters, particularly for the stuff that it deployed. If you launch a cluster with DigitalOcean, for example, and then you import it into Rancher, DO gave you a config, so you can still talk to it that way. But if Rancher launched it, Rancher is the only thing that knows how to talk to it, and that's really what you want for security. You don't want to also, leave all these extra config files out there for backdoor access. You're absolutely right that if the Rancher server dies and oh my gosh, the world has come to an end, you're going to need to redeploy the Rancher server, reload your backups from etcd, and then you should be fine. You'll continue to work. If you don't have etcd backups, then you're in a much worse state. And while I can think of a bunch of really painful steps to get your cluster back online, all of them are much more painful than just make backups, dude. Make backups, keep your backups. Rancher server dies, it's trivial, redeploy it, put it back up, agents will start talking to it, and life goes on. It's designed to be really resilient.
Awesome. Okay, cool. The next question is from Nikolai, who says, the Nginx ingress is available out of the box. Do you have plans to extend the selection of ingress types in the future?
I don't think we do. I'm not sure if that's on the roadmap because there's no benefit to us for doing so. What we can do, let's see, you want a custom cluster, cluster options, show advanced options, Nginx ingress disabled. So now you can deploy a cluster without it. And then once your cluster is up and running, change my screen here. Once your cluster is up and running, you could then deploy, come to the system project, whatever, come to catalog apps and say launch. And you could search for proxies out there. Traffic. So you could just go and deploy traffic. There's no additional benefit for us to let you choose one versus the other. It's just, most people are fine with the Nginx ingress controller, and if you're not, you know it, and you'll probably want to deploy your own ingress controller with values that you control anyway.
Okay. Awesome. All right, next question. What is the best process for backing up Rancher HA? Is it only etcd snapshots?
Yeah, that's all you need. Everything about the Rancher server and everything about Kubernetes is stored in etcd.
Awesome. Okay, great. This next one just came in from Scott, who says, is there a way to do scalable deployments or stateful sets using vSphere storage class, or do I need to fall back to NFS or something else?
That's a trick question. Is there a way to do scalable deployments using vSphere storage class, or do you need to fall back to NFS? Okay. Let's say deploy. So what you're talking about is up here. This is different from storage. So if I'm deploying, scalable deployment of one pod or 3 pods or whatever, workspace man should be in training, so I don't screw up my production environment. So scalable deployment of whatever or stateful set of whatever, you already have a Kubernetes cluster running somewhere because you're talking to it. If you said vSphere, so you've got some virtual machines and you deployed a cluster into them, and now you're talking to them. And now you want these pods to be able to provision storage from the vSphere storage class. So that tells me that out here at the cluster level, you have something here that shows up as vSphere because you installed. So for example, all my OpenEBS stuff here is all system. Oh, here's an example, NFS client provisioner. So you've installed a vSphere storage provisioner somewhere in your cluster, and that makes more options, whatever. That makes something appear down here where I can say, add a new persistent volume, and I want to say that I want this to be the NFS client thing. And so except yours would say vSphere, and this is data or whatever. And you would just deploy your pods or your stateful sets, your deployments, your whatevers, point it at the storage class, and then the vSphere would just either create individual storage volumes for each of your pods or whatever. It's not actually connected. Let me add one more thing there before you jump to the next question. If you want shared storage, you're gonna need NFS. There's no other solution that does read that does sorry, brain gap there. There's no other solution that will allow you to mount a single volume on multiple things other than NFS. So I don't know actually if vSphere's storage volumes have anything that does that, but I suspect that they're more for provisioning something, static volumes like EBS volumes where you get one per pod. That's it.
Okay. Yeah, so so Scott just put in a clarification. Says I'm not sure if this will change your answer, but he says to clarify the VMDK storage, vSphere uses uses only allows one pod to communicate with it. It locks other
Yep.
pods.
Yep. So that's not the right solution. That's called suddenly I can't remember the Kubernetes reference for it. So let's come out here. Let's go to volumes, add a volume, new persistent volume claim. There. So here are your options: single node read write, many node read write, and many node read only. Anything that is block storage can only be mounted in one place. Your VMTK volume is block storage. It's like having a disk. You can't have your disk simultaneously plugged into two computers because there's nothing that prevents two systems from writing to the same block, and then you've got data corruption. In order to do many nodes read write, you need something that sits in front of it that handles that, which is NFS is the easiest solution, or you start getting into really sketchy, well, not sketchy, but delicate active multi-master type solutions. If you're in the vSphere environment and you want stuff mounted in multiple places, you're going to probably want NFS. If you don't have an NFS server, then check out all right, so you saw the NFS client provisioner. NFS client provisioner takes my external NFS server and it creates storage on it, and then it mounts that storage into workloads, whatever they might be. There's also the NFS server provisioner. And what you can do is you can create a VMDK volume of whatever, 10 terabytes or something like that. And you can then run this attached to that volume, and it acts as an NFS server within your Kubernetes cluster. And now you can run workloads that use the NFS server provisioner, and it will carve up that 10 terabyte block volume into smaller pieces and share those out into the cluster as NFS volumes. It's pretty cool.
Awesome. Okay. Thank you for that thorough response. All right. We just have a couple more. This is from Alan, who says, I got PV built on top of an NFS share. I would like to use a Helm chart from the repo, which is expecting storage class, where the NFS option is not default available. Is there a possibility to reuse a similar approach from with PV from the GUI or console? You might need to look at the question because I think the English is a little.
Yeah. Okay, hold on. Let me dig it out
Yeah,
here.
yeah, it's from Alan, right near the top.
Questions. Oh, about some time there. So many questions. You guys are all very interactive. Am I related to Phil Coins? No, I am not. Um, so Alan, there we go. I got it. I got PV built on top of NFS share. I would like to use Helm chart from repo, which is expecting storage class, where it's not NFS option by default available. Is there a possibility to use a similar approach for PV from GUI or console? That is, so there's not enough information there for me to answer. PV built on top of NFS share. I understand that. I'd like to use Helm chart from repos expecting a storage class. I understand that because Helm charts expect a storage class because that abstracts away the need for physical volumes. We're not having options not available. There's a possibility to reuse a similar approach to PV from GUI or console. I think I can answer this by saying that if the Helm chart wants a storage class, you can't force it to use a physical volume. You could manually deploy stuff inside the GUI out of the Helm chart, but you lose all the benefit of having the Helm chart. If you have an external NFS server already, then use the NFS client provisioner to create a storage class. Cluster storage classes. So use the NFS client provisioner, which you see is configured to talk to. Okay, so I can't edit it here because I already built it up. Anyway, use this, point it at your NFS server, it'll create a storage class, use that in the Helm chart, and then you're done.
Sweet.
Yeah,
Sweet.
sorry.
Awesome. Okay.
I need to start saying over when I'm done answering a question.
I'm like, oh, there's more. I don't know.
Over. Roger.
Okay. Cool. All right. This next one's from Stefan, who says, I would like to run Windows VMs as a Rancher VM in combination with GitLab Runner to set up a CI infrastructure. Could you talk about Rancher VM?
Yeah, Rancher VM is really interesting. I was just talking to a guy about that. Matthew said at the beginning that we were just at our company-wide event in Las Vegas. I live in Chile, so I was talking to a guy from the Arizona office who's working on that. It's actually one of his two projects, that and Longhorn. And I'd heard of this Rancher VM thing, but it's not really documented anywhere. And I'm always amazed when people discover it. So I turned to him, we're on this bus going to an event, and I'm like, dude, what is this thing and why? Rancher VM, for those of you who don't know, is essentially a way to run virtual machines inside of Kubernetes. So it's like Inception. You know, you've got a virtual machine environment into which you deploy Kubernetes, into which you can run virtual machines. And the obvious question is, why? Because like if you already got a VM environment, just run the VMs there. But the reason that you want to do it is exactly like Stefan described here, where he wants to run Windows VMs inside of Kubernetes because he wants to be able to fire them up as part of the CI infrastructure. And all of the tooling for plugging a Kubernetes system into a CI/CD system exists. So you can spin up Windows VMs running inside of Kubernetes and then do stuff with them and then tear them down again. Great. Rancher VM exists, and it is still experimental. But I can tell you, I can't give you a release date, but I can tell you that it is under active development. But because it's experimental right now, I don't recommend that you run it in production because things are going to be changing. Just keep an eye out for it, and there should be more information coming out later this year.
Awesome. Super cool. Okay. Next one is from Neil, who says, he's getting this error, and he says, persistent volumes test PV is forbidden. Error querying AWS EBS volume. AWS cloud failed to find cluster ID. I'm getting this error when trying to get kubectl to get a PVC. Any ideas?
Yeah, so that's actually more of a support question and not best suited for this environment. But if you find me on the Rancher user Slack, my name is Adrian. Shoot me your question there, and I'll do my best to help you troubleshoot it.
Awesome. Okay, cool. Next one, only two more. Next one is from Christopher, who says, isn't the Gluster FS or Ceph FS read write many? I guess it's more resilient and better read write rates than NFS.
Yeah, so Gluster and Ceph are two of the cluster solutions that I said tend to be, I can't remember the word that I used. I used a word that was not the right word, and I used another word, but essentially they are much higher overhead. And from an infrastructure perspective, despite the fact that you could technically run Ceph inside of Kubernetes, running Gluster or Ceph is an entirely new skill set. You can also look at doing active-active DRBD stuff. There are cluster solutions out there that do stuff, um, but it may be more overhead than you are willing to take on. And also, when one of those things goes south, you're in for a world of pain. Um, it's much better to find an easier solution. Okay, depending on your application, if Gluster and Ceph, if the read-write performance is so significantly better than NFS that you need that level of low latency, then it probably is something that's worth investing the time learning how to use, and you probably work for a company that's willing to pay for support or Red Hat licensing or whatever to run those technologies. In that case, knock yourself out. Because this is an intro to Kubernetes question or training session, I try to favor solutions that you guys can run at home, that you can run in small clusters, that you can run on some Raspberry Pis. So I'm not going to recommend that you go and build out a multi-node cluster environment and take that beast on before you start learning how to use Kubernetes.
Makes sense. All
Over.
right. Over. All right, here we go. Here's the last question, which I think you kind of addressed already, but it's from Hyphem, who says, "How does Prometheus work with Rancher?"
Um, how does Prometheus work with Rancher? For that, I'm going to actually ask that you look at what was it, a meetup from December,
Yeah,
Matthew?
our
You
online
did?
meetup. Yep.
Yeah, okay. So look at the online meetup from December, and they're going to talk about the new Prometheus integration that's coming out in Rancher 2.2. Since there's a meetup where they're demoing it, I guess I'm able to talk more about it. We are using the Prometheus operator to deploy Prometheus per project, and then backhauling some of that data into a higher level Prometheus, and then exposing that data for either project-wide metrics or cluster-wide metrics, depending on what level of access permission you have. And then out of that data, we are able to not only generate alerts, which is what we do now, but we can also make more intelligent decisions about things happening within the cluster.
Amazing.
Over.
Over. Okay. Well, that is over. There's no other questions. Um, so I'm going to go ahead and take the presentation back to just show the last couple slides.
Yep.
Um,
Before you start on the last slide, and
yes.
before all of everybody starts logging off, which is what happens about this time,
Yep.
I am the real Monakis on Twitter. You can also find me. I'm Adrian Goins on LinkedIn. There are two Adrian Goinses. One is this black dude who works for Aetna. That is not me. I'm the other one. So if you guys like what you heard today, please follow me. I post articles, I post content, and I would really love to engage with you in the community.
Absolutely. Awesome. Thanks, Adrian. Okay. Can you see my screen?
Yes, sir.
Okay, awesome. Just a reminder to everybody for the Slack resource. You can join there, join the conversation with many others. Adrian's mentioned it a bunch of times as a place to reach out to him. So please, highly recommend to do that after this training if you're not already there. And that's it. We will have a survey at the end that you could offer some of your feedback on what you liked, what needs improvement for these trainings. And I will mention that we are about to start a new training track. We're going to switch these trainings up as well to give a little bit more time for Kubernetes and a little bit more time for Rancher. So please check the training schedule. You go to rancher.com/training and you will see those. I believe the new training track will start not this week, but the following week. And you'll probably hear an announcement, or you can go to the page to find out more. That's it. Thanks again, everybody. And Adrian, amazing job, as usual.
Yeah, thank you all for staying late. I really appreciate it. Take care.
Okay, bye, everybody.